Okay, here we go. You might have to pause the video a few times to see exactly what's going on here. This graph down here is the graph of the function f of x equals negative sine of 2x minus cosine of 4x from 0 to 2 pi. And here this g of x has the identical graph. The question is, how did I get to here? And where that graph crosses the x-axis, those are the roots of that function. And you can see I've got answers of pi over 4, 7 pi over 12, 11 pi over 12, etc. How did I get to that? Or how do you get to that without graphing? The key is that, well, there's a couple ways to do this. One of the most straightforward ways is to use the double angle identity for the cosine of twice an angle. There's three options, one of which is this one, 1 minus 2 sine squared of x. And that's the one I'm going to use because my goal is to end up with the quadratic equation in terms of sine. So if the cosine of 4 times an angle is what we want to simplify using this identity, think of that as the cosine of twice 2 theta. So this 2 theta corresponds to the x in this identity. And the cosine of twice x is 1 minus 2 sine squared of whatever x is. 1 minus 2 sine squared of 2 theta. So here's the original equation written with the cosine of 4 theta replaced with that equivalent expression. And when I remove the parentheses, I do get plus 2 sine squared of 2 theta minus sine of 2 theta minus 1. This is quadratic in sine of 2 theta. And if that's hard for you to envision, then use u substitution. Let u equal the sine of 2 theta. And then this is what you can write right here. You'll see you get 2u squared minus u minus 1, which is easily solved by factoring. U equals negative 1/2, or u equals 1. But u is the sine of 2 theta, and so this is what I have right here. Now, how do you get to theta from there? Well, if the sine of 2 theta equals negative 1/2, then 2 theta is the angle that has a sine of negative 1/2. Or 2 theta is an angle that has a sine of 1. If you use the unit circle to figure out what 2 theta is, think of the special right triangle 30, 60, 90. Or in this case, sine is negative in the third and fourth quadrants. And if I put a negative 1 here and a 2 here, this angle right here has to be pi over 6. So the original angle has to be pi over 6 plus pi, or 7 pi over 6. Or this angle is pi over 6 right here, because this is a negative 1. And we think of it as a negative 1 over 2. So that's 11 pi over 6. Pi over 6 short of 2 pi. So 2 theta has to equal 7 pi over 6. But we can keep going. Sine function is periodic, so it repeats every 2 pi radians. So here we normally would say 7 pi over 6 plus 2k pi, k any integer. We won't be letting k equal any integer. We just want to let k increase until we're outside the interval from 0 to 2 pi. So if 2 theta equals these two values right here, if I divide both sides by 2, I get 7 pi over 12 plus divide 2k pi by 2, I get plus k pi. Let k equal 0 or 1, and you'll see that you get this angle right here and this angle right here. Now, if you let k equal 1, then you're going to get 7 pi over 12 plus pi, which is 7 pi over 12 plus 12 pi over 12, which is 19 pi over 12. And there it is right there. And similarly for the 11 pi over 6, we'll let k equal 0 and k equal 1 for this plus k pi, and that gives you these two angles right here. And over here, when 2 theta equals pi over 2 plus 2k pi, theta equals pi over 4 plus k pi after dividing by 2. When we let k equal 0, we get pi over 4 right here. When we let k equal 1, we get pi over 4 plus 4 pi over 4 is 5 pi over 4. If we let k equal 2, we go outside the interval ending at 2 pi. So we're done. There's your 1, 2, 3, 4, 5, 6 solutions to this trigonometric equation. Okay, so be sure to pause the video, take notes, and see if you can follow along. If you have any questions, post a comment.